Alan, we're here at the FQXI conference. You and I have been at many for many years. This time we're focusing on the physics of the observer. And this goes back maybe 100 years, the beginning of quantum mechanics. So why are we still talking about observers, and what are observers, and particularly from your point of view, from the standpoint of cosmology?
Right. Well, I'm the kind of old-fashioned physicist who likes to think that the laws of physics themselves don't care about observers. And that issue, of course, did get somewhat complicated when quantum mechanics was invented, where the Copenhagen description of quantum mechanics made the observer fairly central to the description of how quantum mechanics works. I subscribe much more completely to the description of quantum mechanics of Everett, many worlds interpretation of quantum mechanics, which takes the observer out of the statement of the fundamental
Is that the only way
laws.
to get the observer out?
I'm not sure it's the only way, but it's I think the most talked about way.
I always felt that to cure the disease of the observer, the medicine of many worlds was worse.
Well, some people feel that way. You're not alone. I don't think it's worse. I mean, the beauty of the many worlds interpretation is the simplicity of the laws. That is, the many worlds interpretation simply says that the Schrödinger equation that governs the evolution of the wave function when we're not looking at it and measuring it is the absolute law that governs the wave function under all circumstances. And that's the essence of the Everett interpretation. And it seems to me that if you're going to believe the Schrödinger equation works when you don't look at the wave function, it makes a lot more sense to also believe that it works when you do look at it.
But the consequences of that are that in some sense you have a multiplicity of worlds beyond belief in terms of the numbers, whether it's consistent histories or actual worlds people sort of disagree or don't really understand. But in a philosophical sense I could go with it, but if they're real actual worlds that are the equivalent of what we're having, it would just seem like an odd way for reality to be.
You're allowed to think it's odd, but I can assure you that you can't think of any good arguments to indicate that you have evidence that it's not that way.
Okay. Okay.
So anyway, that's I think most people working in cosmology do take the Everett point of view. Largely because other points of view really talk about observers and how observers interact.
Just don't work.
And it doesn't work in cosmology. There are no outside observers. So I think the majority of us have adopted the Everett interpretation as our preferred. And if you think it's weird to have that many different branches of the wave function, you're entitled to think it's weird.
Okay, so basically by assuming a multi-world Everett view, you're just throwing out the whole problem of the observer and just saying it's irrelevant because it's solved by that. I don't have to worry about it.
That's right.
End of story.
End of story, except it does re-enter in cosmology, I was planning to say.
Okay.
Because it comes about because of this problem of eternal inflation and the difficulty of defining probabilities in eternal inflation. The basic issue here is that most models of inflation, excuse me, most versions of inflation have the property that once inflation starts, it never stops.
Right.
And that's what's called eternal inflation.
Right.
It's really just future eternal, not eternal into the past. And that leads to a very difficult problem of defining probabilities. Anything that is allowed by the laws of physics will happen ultimately an infinite number of times. So to say that something is more common than something else, you're comparing infinities, and there's no unique way of doing that. So that has led many of us to be worried about this question of probabilities, and we've been exploring, I should say, different recipes for how to regularize the infinities, to give rules for how to compare one infinity with another. And in order to talk about such things, we really do need to talk about not solely what happens physically, but we need to talk about what we expect observers to see, because that's ultimately what we're trying to predict, what we would say. So the observer enters by basically picking out parts of this multiverse, which are the parts where observers live, and we have to condition our probabilities on those observers. We have to ask, what's the most probable thing for an observer to see?
So an observer in cosmology really has a different characteristic than the observer, which is sort of a measurement or an interaction in quantum mechanics. The observer in cosmology sounds like a real observer,
Yeah,
as
that's
opposed
right.
to a measurement or an interaction in quantum mechanics. All right?
That is right. That's exactly right. And in fact, I've certainly heard people debate about how exactly we should define observers. In fact, it's a common debate. Clearly, you and I count as observers. As a grasshopper, an observer. As a monkey, an observer. If there are creatures very, very different from us, should they be counted? That's led to a lot of discussions. But I think there's really, at least I think there's really a simple answer to that from the point of view of understanding how we make predictions in the multiverse. I think if whatever class of observers you or somebody else has identified, which may or may not be controversial, I think if you narrow that class in an unbiased way, you'd still expect the smaller class to be representative of what you see in the multiverse. And the one beauty of the multiverse here is that the set is infinite to start with.
Yeah.
So no matter how much you narrow it, it's still infinite. So I think the least controversial thing is that if I want to make predictions about what I will see in the future, or what I will find as a result if I do some kind of an experiment, I can look at observers who are all exactly like me. Atom for atom, if one likes, or thought by thought, if one thinks that thoughts are the more important thing. I can look for observers that have exactly the same memories as me and the same thought processes as me. And I think that's the simplest way to describe how one would pick out the observers in a multiverse to use to make predictions. One still has this measure problem of how to count them, because there's still an infinite number of them. This does not solve the measure problem, but it is, I think, the right answer to the question of how do we pick out the observers that are relevant.